So myself, Sai, and currently working as a software engineer in one single. Today we are going to present the topic of cryptography. So what is the cryptography? And we'll see all the topics in detail. What are the modules that is offered by Mulesoft? And yeah. So generally, what is cryptography? Cryptography is the science of technique. We use some mathematical calculations and algorithms to ensure data integrity, data security, because nowadays data is increasing huge, and it is not, cryptography is not confined to MuleSoft. It's a universal. Cryptography is not confined to one language. So if you see any of the cyber security and like a big crypto coins also using the cryptography concept. But luckily enough, MuleSoft also came this topic in our projects to ensure our security applications that you are developing. So it's basically to ensure any of the, we'll see in next slide. So let's take this example. What is cryptography in detail? So two people are communicating each other some information carrying over the internet. So there is a third person, that is watching your communication. So how you see best secure your communication, that no like intended third party user should not visibility should not see your message, because you will communicate communication over the digital internet. So cryptography has the flavors. So to use it different techniques, we will see what are the modules and all those things. So what is in MuleSoft, the cryptography module is not the pre-uploaded component. So we need to go for the exchange and you need to download the crypto module. So if you download the crypto module, these are the different flavors that is offered by MuleSoft company. PGP, it's JCE, XML. XML cryptography we'll see last, because it's a less user, not less user. It's a legacy systems are using, but recent terms we are using PGP and JCE. Checksum. Checksum is also one of the technique to ensure our authenticity of our information. So we'll see all the things in the detailed discussion. And moreover, people will confuse at HTTPS protocols, and there also will use some type of digital certificate, and cryptography also will use. So if you need to see it security is not confined for one layer. So if you see you're developing any enterprise application, so security will be in the different layers coming from the domain network level, and you will see the transport level, and next level is like your data level, and different type of security. This is also one of the security ensure between your application to API call. So we'll see all those things. So JC encryption. So JC encryptions is basically flavors comes with the two flavors, password based encryption, and before that JC is a Java cryptography extension. So it is developed by Sun Java cryptography module, library. The like Sun systems have developed this cryptography module, Java cryptography. It's purely based on runs on the Java libraries. Uh, it comes with two flavors. So if you see here, there are a lot of modules. If you see import our connector, you'll see a lot of things. But here you will see two things: password based encryption and key based encryption. So key based basically will do with the digital certificates. So people who's working closely with the security pass will have the idea of digital certificates and all. We will encrypt the things using things. See, password based encryption look like this. So you don't have anything, any certificates will be used in this type of encryption. It's purely based off algorithm and password. So you give input any of the payload or your API data, what are the API data that is coming. So you give that, and you need to encrypt the data using some algorithm and password. So you need to just drop down the algorithm, which algorithm you need to pass it, and you need to give some password. So once the data is received to the target system, they need to decrypt with same algorithm and same password. So because see, once you are sending the API data from API to API, so not if you don't want to send a plain visible data, so you need to encrypt using some algorithm and password. You can use this component encrypt PB and decrypt PB. So this is like encryption, and other part is like a decryption. So you need to use these things to use it because it's like less secure, because anyone who has known this password, they can able to see your data. So it's a less secure, but it's again up to you where which each use cases you need to use these things and all. It's basically comes in our project structure, and comes this is the main important thing, GC encrypt. And one more thing, if you have any questions, feel free to ask me and ping me in the like chat box. So I'll answer in between. Once completion of some slides, I'll take the questions. Feel free to ask the questions. JC encryption. Yeah, JC encryptions comes with two things: symmetric encryption, and one more thing is like asymmetric encryption. So we need to clearly understand these concepts like symmetric encryption and asymmetric encryption. Symmetric encryption is basically same secret key will be used. We will generate on secret key, like source A is talking with source B. Will give this clear idea, symmetric encryption. So if you look at this diagram, like source A is talking with source B. So same key will generate one secret key in between source A and source B, and that secret will be shared by two parties. So it will be the secret key will generate by some algorithm, and that secret key will be given by source A and source B. Source A will encrypt the data using some secret the say secret key, and will send the data to source B. Source will B will decrypt the data with same secret key. That is like symmetric. So both parties will use same key. That is secret key will be used. That's a symmetric. Asymmetric encryption. So here we need to have the concepts called digital certificates. So if digital certificates means digital certificate will have public key, private key. I will have two things: certificate, private key, and public key. So the three will be in the one set. So if you generate any digital certificate, you will have certificate, private key, and public key. So now Bob is talking with allies. So allies will share their public key to Bob. So because Bob is sending some information to allies, so he'll ask the allies, so send me your public key, I will encrypt the data using your public key and send to you. Because private will be in the allies side, so he won't share. So keep it in mind that no any case we should not share our private keys. Private keys will be kept in our side. So whenever you are anything you are sharing, you need to share only public keys. You should not share private keys. Any situations, private key will be sit in our side. So like Alice will send the public key to Bob. Bob will encrypt the data hello Alice with the public key of Alice, and it will send to Alice. The message will encrypted message will be received to Alice. Now from the Alice side, he need to decrypt the like what is the encrypted data with using Alice private key, because private key public key will be there in the one set of digital certificates. So no other can and other people cannot decrypt using another private key, because so three will be there in the one set of things. So no one cannot be who are having that combination of that private key and of the public key, they only can decrypt the message. This is more about asymmetric. So different keys, anywhere different keys will be used, that's a asymmetric encryption. Same key, secret key is used, that's a symmetric encryption. That's the difference between will get confused like asymmetric. Asymmetric is more about, we'll call as a public key cryptography. So technical terms will call as a public key cryptography. Public key cryptography is asymmetric encryption. So Keystore is the one of the famous tool. We can generate the self-signed certificates, not the CA authority certificates. So what is the difference between CA authority? You'll see the terms called CA authority and the self-signed certificate. Yeah, I'll give simple example. Like self-signed certificate is like you are you go to any of the bank to open your bank account. So people ask you, like bank people will ask you, give me your ID. So any of the government ID. So if you give your self-signed ID, like you generated some your itself on ID, so bank will not accept your ID. So bank will accept only any of the PAN card, any of the government proof, because that's again the proof that bank will trust the government proof. So that's the difference. So if you see develop any of the certificate, it's CA authority, like globally it will be trusted by a lot of customers. So most famous CA authority certificates is like a DigiCert and a Verizon, and these are the famous CA authority certificates. So it's self-signed certificate can be used internally, and if you are doing with any of the customer, outside customer, like CA authority is that trusted by globally. So that's the difference. So self-signed is like basically you are using your internal, and if you are going with CA authority digital certificates, then it's like globally trusted by. So like project for company B. So company will not trust you. Company will trust you the CA authority. That's the difference. If you develop self-signed, so it's not authorized by any of the companies. So they will trust CA authorities, not B. So that's the difference. So here in our demo, we can generate key store explorer. Key store explorer is a tool, is a tool that you can generate self-signed certificates. So or you can go with OpenSSL and key tool command. That is based on the OpenSSL, and this will run on the internal JDK thing. So you can, because it's a UI based, you need not run any commands. So key store explorer configurations they look like this. JC configuration is not it's like a key based encryption of JC. That's password based, you'll have only encryption algorithm and one password. Here you'll have key based on algorithm, key based with a combination of algorithms. If you see this diagram, you need to pass the .jks. .jks is the key store format. You'll have three extension .jks, jks, jcks, and pkcs tool. So these are the three different extensions that we use here in the JC. Yeah, that's all about the configuration. So what are the key? You need to keep that certificates, whatever private key and public key in the SRC main resource folder, or you can keep it somewhere. You need to call this here in the key store .jks format. It's not. It's basically key store is like, it's like vault where you keep all your keys. So it's like a parse. You in parse you will keep money, like how you keep the money. Same thing here. Money is like a keys. What are the keys that you are using? And parse is like vault. So vault will have some secure password to open. So that passwords will run open in the runtime. So it will be inside your project jar. It will be in the safeguard. Your private key and public keys will be there. So that's more about the dot. That's like, it's like extensions will be basically for walls to keeping your security of your private keys and all. Cypher is all about, we'll discuss in the next demo time. Algorithm you need to pass here, and what are the key ID? Here you need to declare key ID, which key ID you are calling. So key ID is like symmetric and asymmetric encryptions. You need to use it. If you are using symmetric encryption, the secret key will be used. Asymmetric encryption, public key and private key will be used. And yeah, any questions? I can take it. Okay, fine.
Yeah. No, sir. I haven't
Okay.
seen any questions in the chat still now. Yeah, we can
Okay.
proceed.
Okay, checksum is basically it's like a hashing of your message. It's not like encrypting the payload and decrypting the payload. It's like a hashing. Hashing is so what is the meaning of hashing? Is like calculating the a payload with fixed length in the hexadecimal format of using some algorithm. That's called hashing. Hashing is like calculating the output. So we cannot decrypt the hashing. So one thing you need to keep in mind, like hashing cannot be reverse. So like how you do the encryption and decryption using JC and public key and private key, here checksums is like a hashings cannot be reverse way. Hashings can be done using only validating sense. You send some calculate some checksum and send to the other party will check it as a security check before the entering your API. They will validate it. If he can able to validate it, then he will think that he can enter into the system. That's like a checksum. Checksum here, you need to provide the algorithm and content. That's it. And the validation side, you need to pass the payload and what are the checksum you generated. You need to pass it. So it's like a conditions. So equal. If they make it equal, then it validate. You'll give the successful response. If the two things like A is something like payload with expected checksum is not matching, so the validate checksum will give some checksum error, crypto validation error. So this is the thing. And crypto checksum can be done using your data view. Data view, we can use it like hash. So one of the thing is like most widely used hashing uh, algorithms is like SHA and DeFi algorithms can be used. So here also you can use it data view model, simple hash value with binary, and our algorithm short of checks are MD5s and can be used in the data view. Here is component here, but one thing is like validation cannot be done using a data view. It's only calculating a hashing. But here component level you can do both calculate and validate. But data view level we can only calculate the crypto hashing and it cannot be validated. That module is not there here. Yeah, this is all about the JC encryptions and all those things what we discussed. So PGP, PGP is like it's more secure and more flavors is more features is available. PGP stands for pretty good privacy. So what is that? So we'll have one question like, what is the difference between JC and PGP? Why, in which cases we need to go for PGP and which cases we need to go for JC? This type of questions will keep in trigger in my on our minds when we're developing any of the encryptions we'll use it. And one thing we need to clearly understood is like PGP comes with additional flavor that it will compress the data and it will encrypt the data. So JC cannot do the compress. So it's a heavyweight. JC is heavyweight. PGP is lightweight because it will do both. First encrypt the data and it will first it will compress the payload and then only it will encrypt the data. So when we are having the requirement to encrypt big payloads, so JC cannot be handle those type of big payloads. So you need to go for PGP. PGP will compress the things because encryption will be fast, and these are the techniques. And not only this thing, so one of the things like uh, people think that PGP is like again the asymmetric encryptions. Uh, PGP is not comes with symmetric means again the secret keys cannot be like secret key type of encryption cannot be done with the PGP and all. So not like that. PGP is a hybrid encryption model, because PGP, if you go internally deep it, dig into the encryption thing, logics and all, you will clearly understood like it's a combination of both. Symmetric comes with a flavor combination with asymmetric. So there in JC, two models is different. So symmetric is one route and asymmetric is two a second route. Like you need to independently develop two things, symmetric and asymmetric in the JC. But PGP is a hybrid. Hybrid means in single module it will comes with both. Both means it will internally use two flavors. So how this is the thing. So earlier I also taught like it's a public key, only public key and private key use it. So when I go deeply and understood the concepts very clearly and internally understood the logic, I came to know that it's a hybrid encryption model. It's heavy security compared to JC. So like when you have a situation where to use JC and PGP, these are the things you keep in mind. So internally, what is happening in between JC and PGP. PGP first will generate one session key. So I will see in the demo how this session keys is generated and how this public key, private keys will be there. But we need to understand the flow and logic internally what is happened. So that's why I'm showing these diagrams very clearly, understood the concepts. If you understand the concepts, the implementation is very easy. So PGP first will generate session key. That's again the symmetric key. That's what we discussed, JC. So that single session key is generated internally in the algorithm. It will generate one session key. Using that session key, it will first encrypt the what are the payload you need to encrypt. So once the data is encrypted, it won't send that encrypted data using your session key to the other party, like receiver party. What it will do is like PGP, then uh, that session key will be encrypted using sender's public key. That's because there will use asymmetric as a data level. Here it will use like session key will be first session key will uses to encrypt the data. That's done. Then next part is like session key will be encrypted using sender's public key, and two will be in the bundle. Session key, encrypted session key, and the encrypted data using your session key. So two will be bundled and will throw to the receiver side. So once the data is received to the decryption side, what immediately the decryption party, like PGP decryption party, need to do is like they need to first decrypt the session key, because using the session key we encrypted the data, not using public key. So first session key we need to get it. Using that session key only we can able to decrypt the data. If you want to decrypt the session key, again we need to decrypt the session key using receiver's private key. So once the session key we key, without session key we cannot able to decrypt the data, because session key is the key role here. We encrypted the thing, and session key is encrypted when you are sending to the receiver side. So session key will be decrypted using private key of a receiver side. Once the session key is got, so you will get the session key will be visible. Then session key will be used to decrypt the payload. So that's what internally logics. It's not like private key and public key will be used to the PGP. PGP here comes with the two flavors. So encryption, asymmetric and asymmetric is a combination. It's a hybrid. So we need to think, we need to see that clearly of what is happening. So any questions here? I need to take it.
Yes, Sai. So yeah, there are two questions. So Shashank,
Yeah.
okay,
How do
how do we validate the checksum at the consumer end? Uh,
Yeah, see, validation will be done by validate checksum. So you need to implement this logic before kit route or somewhere before entering into the actual API internal logic. First step, once you receive it, so they will send you, sender party will send you the checksum. So you need to validate in the like receiver API. You need to implement this logic using validate checksum component. Then only if you allow, if you validate is success, then only you allow to the next steps in our API. If you are not able unable to validate using the validate checksum component, then you throw the error for not one unauthorized. Got it? Who generate the session key in PGP? Can session key be static and dynamic? Yeah, session key will be generated by the algorithm. It's a random key will be generated by algorithm itself. Yeah, I will show in the demo how it is generated in the PGP module. So it is like machine generated PGP, machine generated session key. We are not able to generate the session key. So PGP module, we need to give the algorithm, session key algorithm. So automatically it will get created by the mission. It's like we are not, but JC we will do it session key. But PGP is like mission generated session key. We are not able to generate. Only we need to pass the algorithm. Got it, Vijay? Yeah, how the receiver will get the session key every time. So session key will be generated by one time, like in the algorithms once you send it. So it will be there in the bundle. So bundle means, so here see, it will be there in the bundle. So decryption automatically get it. I think it's in the base 64. It will be encrypted. So here, 1 minute. So it will be there in the session key. Decryption will get the session key. So first he need to decrypt, right? He need to decrypt using private key of your receiver side. Got it? How the receiver will get the session key? So receiver will send it, right, both. See, ciphertext plus encrypted session key, two will be in the bundle in the send data sending. So once it is received here, we need to decouple it using our decryptions. We need to send both ciphertext plus encrypted session key. Got it? It will be travel. Do we have a possibility to have the session key then? Being a one-time session key is the loose end. Do we have a possibility to have the session key dynamic? So it's again the dynamic. We cannot have the access and all those things for the session key. We cannot able to see it. It will be internally the logics in the algorithms. We cannot able to see those things session key. It will be a machine generated thing. We need to pass only the algorithm. That's it. We don't have any access for the session keys to change it, or we cannot able to see also. So it's like internally it will happen. Got it, Vijay? We'll discuss more in the demo. So that's all about encrypt. Uh, so Cleopatra is one of the things you can do it. A creation of PGP key pair. Uh, See, Cleopatra is one of the thing. There we use key tool. Here, Cleopatra is one of the things you can use it for creation of the things. Here we use fingerprint, passphrase, and all those things. Fingerprint is about the is like authenticity of our gods, authenticity of our keys that you keep in the some vault. So here again, uh, PGP will comes with .gpg and .pgp extensions. So that's the thing. There JCE, JCE PKCS stall is the three combinations that you. These are the commands that you need to pass it. Git bash here is the command you need to pass it. These are the tools. These are the Cleopatra is the tool to generate it. Here it's about the commands you need to pass it. Git bash will use it to generate PGP key pairs, and PGP looks like this slide. So here fingerprint is about the see, we'll get this requirement like you have 10 keys. You can keep not one key. You have different functionalities with the different keys. You need to grab it from the key store or vault from where you stored in the SSM in this system. Let's take 10 keys. You keep it in one vault in dot key store extension or dot BGP extension. So so how you identify the which key you need to call it? So here we'll identify using fingerprints, because every key will have different fingerprint. If you pass this fingerprint from this, see, this is the path you need to call it. In that path you can have multiple number of keys. You can keep it by using the fingerprint. It can identify which key I need to take it. Like this is the requirement where will come different keys you can keep it, and you need to, based on the choice conditions, you need to encrypt the things and all those things there. Don't keep in different keys. Like you have 20 keys and 20 encryptions need to done based on the conditions. Don't keep 10 20 keys in the SSA main resource and you don't call like this. Keep 10 keys, 20 keys in single key store, and call. Here it's a fingerprint, and in JC you use alias. Alias is the thing where it's dynamically changes based on the. So that's all about requirements comes. Uh, it's like it's a standard way to use it. Signing. So as we all know, signing is a technique. So you will see people use to see these terms like digital signatures. So you'll widely use a digital. You will see frequently digital signatures. So digital signatures is like to check the authenticity of your message that you receive to the target systems. So one thing we need to keep in mind is like digital signing cannot be done using public keys. So let's take here Bob is sending to the allies. So Bob will digitally sign using some private key of Bob will send to you allies. So Bob will send his public key to the allies. So allies can only validate the digital certificate like the message is received to the Bob or some other people. So how can it's decrypt like not decrypt? It's like validation. So he if he can validate it, so he can clearly identify that okay my message is received to the Bob identity. So that's like you allies will have different identities. So this is like is like authenticity of the things. So how it will be digitally signing? Digitally signing is like first payload will be done using some hashing. Then hash message will be encrypted using the Bob private key, not public key. He won't do digital signing with any of the public keys. I'm sending message to you. So I will digital sign using my private key and I will give you my public key to validate from your side. Who are the trusted customers I have it. I will send my public key and they can validate because I'm sending message to you. So you need to validate it. That's the difference. But encryption and decryption is slightly opposite. So there is like public key, private keys, sharings and encryption, decryption will be the. But here only signing will be done anywhere. It's a universal anywhere can be done using private keys only, not because I'm sending some digital certificates to you. I'm just signing. So here verification part, what they will do is like so hash first they will generate the hash in the because in the signing will have the hash algorithms and what are the algorithms the message description will have all those things. So it will generate the hash and in the signature what we will do is like signature need to be decrypted using the sender's public key because I will send my public key to the like who are the customers I have. So they'll decrypt the signing not yeah, decrypt the signing using public key and you'll get some hashing. So they will equal it both hashings. So if their hashings is fine then they can say that signature is valid. If the signature is unable to validate then he will throw the error 401 unauthorized. Some people has tampered your message, some people has hacked your message. So that's all about. And PGP comes with both encrypt and sign. So encrypt first we can do it but JC cannot be come with both flavors. So here we can do with signings and encryption can be done in the encrypt and signing component. So here first they will do sign and then we'll do encrypt. XML encryption is like a very old way of traditional. If you see any of the legacy systems that is developing in 1980s, they're using XML encryption, and here also they're using .jc key stores only. They're not using PGP and all those things. So here same thing. We need to pass the key ID. Key ID means that you are referring to the things what you are saved in the global elements of the key store. Same and algorithms and all those things. Signing same thing. Signing we need to pass it. So here this is the last slide. We will go for the demo. So attached and detached signatures we need to have the XML things. XML will have different type of signings. So signings like enveloping and detached and internally detached. I'll show in the demo part what is the difference between enveloped means you have a XML element. First will be the plain XML data. In between you'll have some signature. So enveloping. So signature will be the root element, and inside of signature you'll have the XML content what you are encrypting the things. That's the difference between enveloping and enveloped and enveloping. That's again comes two things will be under the umbrella of attached signatures. And detached is like detached and internally detached. Detached means completely two things will be decoupled, and they will be having them some external reference ID will be there. But here two things will be in the single root element. Here it will be decoupled. Internally detached have this data structure, this structure of XML content. So we'll see in the demo part. All about the content. Yeah, I'll go for the demo because it's like it's a big concept. We cannot cover all this. Uh, because I need to skip some things because these are a lot of concepts we'll see in the demo part. First, we'll go with the JC. So how to generate the JC? So JC is like this is the Keystore Explorer, Keystore Explorer. So here I'm generating only self-signed certificates. I'm not going with the CA authorities. Again, CA authority you need to purchase from the people from the CA authorities. New file, JCE case and JKS. So JKS. So generate key pair. This is the key size. So what we use the key size is like we this is like bits. Bits is nothing but if you use this bits internally algorithm use this many number of combinations, set of combinations will be used for that bits to encrypt the what are the payload that you are. If you are increasing more bits, then you can say that your encryption is more complex because internally algorithm use that many number of bits to encrypt the data. If your bit size is slow, if bit size is small, then your encryption logic will be somewhat reduced. So that's why, because if you are increasing more number of bits, then your encryption again the encryption mechanism will get slow. So that's again the requirement comes. If you need the encryption will be fast, then you need to decrease the size. If you decrease the size of bits, then it's a compromising of your encryption. If your encryption will be more secure, but it's less slow means because it use will take some combinations, right? So that's the difference. DSA, RSA, DSA, and DEC, these are the algorithms generate key pair. Here you need to pass your common name. So common name is basically this is again separate concepts like domains. They use common names, organization name. You can use any of the things. So just okay, create. So is as I told, alias is the thing we need to pick it. We have 10 keys. So this is the keyword you need to pick the 10 different keys you need to pick it. That's the thing here. Okay, keypairs generation. See, and one more thing, any of the things you see here, red mark, then it is like your key is expired. So expired. Green means it's already valid, have the expiry date, no expiry date. So here, see, every certificate will have three things: certificate, private key, and public key. These are the things. So you need to keep in, and you need to just save it. That's it. Save as. You need to save as in your, you need to again this is the passwords that you are keeping to vault means as I discussed, you have pass to open pass, you have some key key to open your how much money is there. So same thing, that's why this is all extensions means to secure your keys. You are not keeping your keys open in our folder itself or in our jar files. You are safeguarding your keys when you are keeping in your projects across multiple servers and all those things. So it will be readable in the runtime in the code itself. So that's the difference. And one thing I observed is like, see, symmetric encryption, you need to go with the JCE case and PKC stall. JKS cannot be done creation of symmetric keys. That's a secret keys cannot be done, cannot be created because JCE key is like updated version of Java cryptography. This is a word, so you won't come this one. So in JCE case and PK test 12, you will get the creation of secret key. Secret key, as I told. So this is the symmetric encryption. So see, this is the different type of algorithms you need to pass. Same thing here in the security properties also, the concept will be a symmetric encryption, DUC, blowfish, AES, and all those things. So and and one more thing, symmetric encryption key size will be less. That's why it's very like secure. If you have asymmetric, that's a more secure way. So here, that's it. Here I need to send it encrypt, JC encrypt, and here see, I'm just keeping where I'm keeping SRC main resources under the one folder. I'm keeping my keys. What are the keys that I'm calling? JC encrypt. So this is my mulesoft.jks key store. This is the file. I have my receiver's public key in the .jks. I kept. Uh, I'm sending encryption data you. I will take some public key from your side, and that public key I will keep in the mulesoft.jks, and we can keep all private keys, public key in one under umbrella of .jks. So I'll keep public key. So how to refer it? So here, if you see here, there is a two flavors in JC, asymmetric and symmetric. So here the it will be independent. It will divide two things. So if you are going symmetric, you need to create symmetric key, and if you are going with asymmetric, you need to pass the receiver's public key. So see, you need to pass the key ID. Key ID is a user defined. You can pass, you can define any of the user ID. And alias, as I told, you have 10 keys. How to identify which key? Because in mulesoft.jks, I have 10 keys. I kept it. Which key I need to pass it here for the encryption? So based on alias, it will pick it. Password here again, I will keep the password for the. Again, one more thing, in the .jks, public key will don't have any passwords, only private key will have the some secure passwords. So if you are passing some password, the component will identify it's a private key. If you don't if you don't pass password, it will identify it's a public key. That's the difference. Public key we don't have any password, only private key will have some passwords. So that's the difference. That's why it is coming as a optional. So based on your things, you need to pass it, because here the encryptions will use public key, we don't pass any password here. So see here, I use, because in the demo I used both things, that's why it looks like both the private key and public key. But in our real times, use only public key one side and private key from other side. They are like in other global elements from other sides. So that's the difference. So here see, key id I pass it, password. This is a private key I'm doing. This private key I'm using for the decryption. This key id where to pass it. So here, way to pass it, go over there, and that key id you need to pass it reference here. So if you are referencing public id, it will take from the global element. It will pick it from go key store explorer, will take the key using based on alias and use some algorithms, and it will encrypt the data. Cipher is about the complexity, is like paddings. Paddings is like a so padding. If you are using plain algorithm, like anyone can, because people have highly intellectual, so they can, even you encrypt. Some people have the know how to decrypt and all those things. In like threats will watch your communication. So padding is like a you use some paddings here. Padding is like you use some random nonsense words, like this component will use before encrypting, you'll use some random number of nonsense data to the encrypted data, then it will encrypt the data. So like they cannot calculate the what is the encryption and all this, because before encryption you'll use some random nonsense data to the encryption to secure our encryption. So that's about the padding. Padding is like adding additional nonsense data, random numbers to the your payload, then it will encrypt the data. That's the padding. Padding is like additional security that you can provide. So here these two things are mutually exclusive. So you need to pass either algorithm or combination of algorithm with padding. So you cannot mutually send two at a time, because either you need padding as a padding with combination of algorithm, or
Yeah. Sai is joining back, guys. Yeah, maybe some network issues. So give us 1 or 2 minutes. Okay, Sai
Sorry,
is here.
sorry. I didn't see it.
Yeah,
Yeah.
go ahead, Sai. Yeah, we can
How
hear
many
you.
minutes we lost? We lost you.
Yeah, we were in that code section where you were showing.
PGP,
Yeah, maybe.
PPGP,
Yeah,
JC is
maybe.
completed.
Yeah, you can like go back a minute, 2, 3 minutes before, and you can resume from that.
Yeah, yeah, sure, sure. See, JC again. See, I used JC here. Different key store. This is key store I'm calling from SRC main resources. Uh, One best practice is like when you are doing encryption. Because why we do encryption? No other party can detect our communication. So best practice is like even you pass some passwords here and everything from SRC main resource and all, even you encrypt these things using your security placeholders in property files. That's the best practice way, because security we need to ensure in every layer comes from top code, every hook of our application we need to see your security. Even best, this is the best practice. Ensure some security place providers here to encrypt, because you don't keep here a plain password here, uh, because people are highly intellectual, they can anything they can see it. So so this is asymmetric, as we discussed. Asymmetric private key 1234 is again I'm calling in the key store explorer, I'm calling my private key. And here if I use public key, I'm calling my public key. Public key we don't have any password, private key will have the passwords. So that's the thing. uh, so here encryption, as we discussed, we use only public key, and we from the decryption side we use the key id. Key id is basically calling that key id. So key id is like first using that module from global element, it will pick the file from the SRC main resources from the .jk. That id will be passed here, like dynamically sending this here to pass it. And padding is like additional encryption that you pass it to your encryption. So I can give simple example, like if you use some algorithm with straight away with encryption, that's a straight away encryption. If you use padding is basically if you give some padding, it will give some random nonsense of data to your encrypted encryption. Before encryption it will give some nonsense, like adding some random number of data to your what are the payload you are encrypting. Then it will combination of that padding data of random nonsense data, then it will encrypt the data. So because people have they have some techniques to decrypt and all of they said, if you use some padding, because it will use that encryption, no one cannot be able to identify which type of encryption. Because before encryption, if your payload will get adding with a random nonsense data. And one more thing, these two are mutually exclusive, not if you are using a padding, you need to pass it here, or if you pass straight away algorithm, you need to pass it here. Two are mutually exclusive. We need not pass both at a time. This is the things you need to keep it mind. Padding is like additional security for our encryption. If you are only algorithm, that's again using algorithm, you can encrypt the data. So that's about the things. And password based, see, password based don't have anything, it's a less secure, same algorithm bb and passwords. So password based and encrypt and bb. So here hashing can also be done using our data view. Using this is again the hashing, it's not an encryption, it's a hashing. That's all about the thing. For the encryption, keep in mind you need to pass it public key. You take from third part receiver's public key and use that public key to encrypt the data. Receiver side, from their side they will decrypt the using their private key. So keep it mind, don't encrypt that things using private keys. Private key always keep in our sides. So that is the thing. And pgp here, this is separated. There is will be in the single module global element. These people in the pgp is different thing, because two things are separated, public keying and private keying. So public keys will be passed here, private keys will be passed here. Here in the jc all will be in the single module. based on thing. It will based on the alias it will pick it. Here also we can keep in all public keys one GPG and all private keys in the one GPG. Based on your fingerprint, it will identify the which key you are reading. It's basically you will keep in one vault, you will reading the keys from one vault. So how the logic will identify, right? Reading mechanism will identify based on the fingerprint. Their alias will identify which type of fingerprint you are calling. Pass security phrase is like as we discussed here in JC also, you see some password, that's a private key. Here also, if you see some passphrase, is a password. It's like identifying the private key. If you don't pass password, it's a public key. Public keys will don't have any passwords. You can keep it open. Open means it will be visible. Don't keep because additional password is not required for the public keys. So that's about the thing. Here binary means it's output binary format. ASCII format, if you want it, use a PGP binary to armor. So here what you need to do is like, see, algorithm. Yeah, one of the Vijay I think is asked how to generate the session key. So see, so you need to think clearly. Think we need to think clearly is like, this is the session key algorithm we need to generate. See, this is the thing we are using for the session key. If we are using some generate session key, see, these are the algorithms, sir. So here this module is already giving these things. So here if you pass any of the session key algorithm, PGP module will generate one session key in the mission. It's not here we are generating the session key manually for symmetric encryption. Here PGP, we need to pass the algorithm. Algorithm will randomly calculate the session key. So we don't bother about the session key generation. So it's the symmetric algorithm to use for encryption. So it will generate the session key, and for using this session key, data will be encrypted. This payload will be encrypted using the session key, and this session key will be encrypted using the sender's public key. So that's what I discussed in the slide. So see, key 123 again calling your public key. Receiver's public key will be encrypted, the session key, and both encrypted session key and our encrypted data will be sent to the receivers. Receiver side, it will identify decryption logic will be identified. I think it's base 64. I think it will decrypt. It will first session key they need to decrypt it. So this component, Mulesoft component will identify is private key 123. We don't need to pass here. Just we need to place the private key. That's it. Key 1234 private key. So how this module is identifying the decryption. So you need not bother about the key passing. So module itself will identify the private key. From the private key, it will take it, and it will decrypt the session key, and after the session key is decrypted, and the session key will be used to decrypt the payload. So then able to see the data. Signing again, the signing is here. Algorithm will be used for hashing. First the hashing will be done using this algorithm. Once the hashing is generated, then hash value will be encrypted using key 12344 That's again the private key. So as I discussed, hashing can be done using private keys only. Cannot digital signatures can be done using private keys. You should not do digital signatures using public keys. That's the difference here. So keep in mind, like when you are doing any digital signatures, when you are creating any digital signatures, create digital signatures using your private keys and send to receivers and share your public key to them. They will validate the digital. It's like authenticity. So that's all about PGP validate. So here you need to pass the payload, and you need to pass the expected signature. So signature will be sent by receiver sender side. You need to pass it. If the two things is validated, then you send the uh, it's like a it's like a validation before receiving to the kit router. You do some validation, then only you will allow. How you do the auth authentications and JWT token validations, and this is like policy level. You can use this is also one of the authenticity to check whether the message is comes from sender side. So XML here, XML also same thing. It will use some session keys. This is also hybrid model, same like PGP. XML is also don't think confuse. It's again the JC where passing symmetric and asymmetric. One thing we need to keep in mind, like XML is also the hybrid model. Hybrid model means it's combination of both symmetric and asymmetric encryptions. So here using these things, it will calculate the session key, and that session key here here using this SHA-126 SHA-1 or something algorithms, you need to pass it using these things. It will give session key and data will be encrypted using public 1234 session key. Using this session key, data will be encrypted, and this session key will be encrypted using the receiver's public key, and both will be sent to the receiver side. Signing again, here you need to have the enveloping detached signatures. So here you need to have these things as we discussed in the slide. See again, wherever you see the signing, I'm passing private keys. So private key will be signed using the things. So a calculate checksum. So I'm just using SHA-1 to 6. These are the different, as we discussed. Checksum is all about the hashings. Hashings means calculating the payload in the fixed length of hexadecimal value. So you will pass this SHA-126 MD5 RCSC 32 algorithm, and you go also payload, and it will calculate some hexadecimal fixed length, and those things you need to pass it for the validation side. Validation again, it will checksum is like you need to pass the expected checksum and will it. So I'll run the project. We'll send it, we'll see. So that's this is a big concepts, that's why it's taking some time to cover all those the concepts. So I cover all the concepts because that's why it's taking time. I covered all the modules that is there. It's not only Mulesoft. Everywhere, cryptography is universal. Cyber securities and bitcoins everywhere. You see, you work with any closely with any of the security, high security systems. The cryptography is the things they will use it internally forever. API to API calls or internally your applications. So that's the thing you need to keep in mind when you're developing applications. Use these concepts in your application. Using these concepts, you can implement your own custom policies also. If you don't want to go, you can keep it what JWT and all these things as a one thing, and you can keep your developing this custom policies before API kit router. Use these techniques. If you're can validate it, then you can give that 200 OK, or you can give that 401 unauthorized error. So encrypt. So I'm just sending it decryption. So one more logic I implemented here is like some people have the requirement like I need to use like a field level encryption. Like masking is the one technique. You will mask the data, but reverse masking cannot be done. So some people have the requirement. I need to encrypt or mask this particular level of security, account numbers, credit cards, any sensitive information of the customer. What I've done, the simple logic is like I use it like this is like flow. I use it flow, not subflow, is a flow, because I use a lookup function. Lookup function, I use simple logic. This function I use it wherever I need to encrypt. This block completely will call this lookup of encryption and decryption flow. So because I need to encrypt by credit card, I'll send it. So I'm just sending it. Decryption side, I'm just calling this logic. See here, I'm just calling this logic wherever I'm, because I kept the particular block as separate. That logic of things as a separate logic, and call using some function. I'm calling this lookup and calling this. So this is the requirement you will get somewhere. Fields need to be encrypted. If you make it any of the things, you will get it error. you will get it error. See, someone has changed the payload, so you will get this type of thing. A requirement based on your requirements you can implement here. My requirement is like field level I need to encrypt. I use a JC for using masking you can do it, but reverse masking cannot be done anywhere. Keep in mind that you do some masking or hashing, it cannot be done reverse way. Reverse way means you cannot decrypt or you can see the reverse hashing. That's the thing. A password base, see password base, because I kept same thing here in the password pb here, password base decrypt pb. See password I kept this is symmetric. Okay. uh, See here I think closing all. See password encrypt pb, I kept two things at a single, so that is why I get here, and I'm closing it, signing. So here you see, you'll able to see the, because I kept, if you change the some password here, you cannot able to see the decryption thing. That's the thing. Symmetric encryption. See, symmetric encryption will be passed, and because it use a single small key, so that's why we are using. So here I'm using symmetric key here. Symmetric key. I'm using symmetric key. I'm using key, single session key. And see, this is the algorithm. You generate one algorithm with some secret key, and same algorithm we need to pass here. If you pass other algorithm, it cannot able to encrypt the data. So what is the difference? Like you encrypt some algorithm, you generate some secret key, because as I told, JC you need to generate outside of the key outside, and you need to pass it here. And PGP internally you pass the algorithm, mission will generate, but JC you need to generate outside, and you need to pass the key ID. See key ID private. I passed it. I think it's a decryption encryption. So because I given private, but single session here you don't use private public key. Here only the single key will be used here. See here I use something. I kept here private 123, but here only single key will be used both sides. And one more thing, keep in mind, like JCEKS and the PKSTS tool is the supported models. JKS is not supported by session keys. So secret keys. If you are creating any session keys, generate using JCEKS or PKSTS tool supported format, because there are updated formats of JKS. JKS is somewhat, it's like JCEK is updated for the JKS, so that's why. That's about the symmetric encryption and asymmetric encryption. If you pass anything wrong value, it will throw error. So could not encrypt the decrypt. You can add some customization messages, so you can add it. Checksum, see checksum I'm passing. I think someone asked like checksum how to pass. See calculate checksum, I pass it. So I'm passing validate checksum from header level. So here what I need to pass it, like both I need to pass it, my payload, and I need to pass my checksum in the header level. So because this is again the valid checksum validation. So here I'm passing. So if I pass anything, I pass any change. So see 401 other. So that's what I told. You can implement some security custom policies. You can implement apart from your OAuth, JWT, and all those things. You can use leverage this cryptography models to implement some ideas, to implement your own custom policies. This is a policy you can implement. If I pass anything wrong, I'll get for not throw this error before kit router. So that's the authenticity of your thing you can implement before a thing. This is checksum using data view. I use it like data view. See data view is the thing. But here, as I discussed, data view don't have support to validate it. You can use something like checksum. Any loggings and all those things to encrypt, to hash it. There you use the this type of data views. So that's all about the thing. PGP will come for PGP. PGP is like here. I'm closing all these things. PGP. See PGP encrypt. I'm just, so see PGP encrypt will have. I think it's a base 64. I didn't check it. I need to check this one. It's a base 64 format, I think so. So once this is base 64, if you decrypt it, you will have some session key. In the session key, you need to first decrypt using private keys of our receiver side. So you need to pass it. So if you change anything, some message, it will throw error. So unknown object in stream, so it should be a complete so that's the internally the logic will be it will run all those things. So if you are go with any java and all those things, you need to write all this code and all the big but the most advantage for buildsoft is like you need to understand the concepts and how to use it. That's it. Background all the component will do it. That's the big advantage for us compared to other technologies. So other people need to write implement and all this logic, call the key stores, all those things, logics and all. But if here in MuleSoft, if you know how to use it, the concept, it's is easy to implement all those things. That's the thing. Compared to other people, we have the a big advantage. So MuleSoft people already done the good job. What our job is like, we need to know how to use it. That's it. See, that's the decryption. uh, don't pass anything automatically, you only pass private key, it will do it. Encrypt and sign, as I discussed. So pgp comes this component, jc don't comes this component. It will do first signing, then it will do encrypt. So receiver side will have the things called fast encrypted data. Inside encrypted data will have the some digital signature. So that's like highly secure communication that is happening between two parts. First digital signature, then encrypt the signature and send to the receiver. So receiver side we need to decrypt the data, and after that we need to validate the internal digital signature. So that's the thing. So here if you are implementing this thing, you are doing both thing in single component. That's the advantage here. But their jc don't come this type of components here. So here key 123, I am referring here to digital signature. This is public key and this is private key, because I'm doing both signature and encryption. I'm doing two things here in the single component. That's why I'm passing two key IDs. Key 123 is the private key I'm using for the digital signature. Key 123 is for the encrypting the data. Two things will be there in the single component. Once the data is received to the decryption side, what they need to do is like validate is signature found. If you keep it true, by default it's the false. If you are using this type of component, both encrypt and sign, you need to use both decrypt and all. So that's the thing. So I'm just sending it encrypt and sign. It will do both encrypt and sign. I use simple some I'd implemented some simple logic here. So, so as I do some encryption, I'm using some cipher, like some value I'm sending to the receiver. Once the data is received to receiver side, you need to take this cipher and you need to validate. If the receiver is cannot able to decrypt the thing, so I'll throw the error 401 on other. So these are the different ideas you can implement in your custom policies using crypto modules. So see, these are the modules. Use these things. Use plain data combination with some cipher value. Cipher is like encrypted data. So receiver side, if we cannot able to decrypt this thing, they will give that error, like error like unauthorized authentication. So that's all about PGP. So XML will go with the thing called XML. XML we can use the single whole payload, or some only the single element you can like XPath you can do it. So pass it, send, and decrypt. Here you pass it. So here we'll have encrypted. XML is somewhat different. It's all that legacy system. So enveloped, see, it starts from message stack to message stack. It's like enveloped. So enveloping, it starts from signature. 1 minute. comes both. I think I've changed it. XML. Okay. Enveloping. I changed it here. It's envelope. It's enveloping. So enveloping will start from signature tag, and it will inside the signature will have some message. That's the difference. So yeah, that's the thing. 1 minute. I'll show this one and close it. I think and it's running. Yeah, that's the thing from my side. I'll show this one and close it. I'll show the attached enveloping and enveloped signatures. 1 minute. See, it starts from signature. Enveloped it starts from message. Inside of message, you'll have in between some signature. Here, you'll have some signature starts, and inside will have some message. So that's the difference between enveloped and enveloping. Detached is like internally you'll have some. It will decouple it, and will some external reference ID will be there. Yeah, that's all about the thing. Any questions? I can take it. Manju, is it fine, right? Audible? Uh,
Yeah. So yeah, I think one question is there from Satya Narayana.
uh, what is the
Okay.
question? Can we pass anything? This is the question, right?
Yeah.
Can we pass anything to the cipher value? Is there any syntax to it we need to follow? JC encryption key. So cipher. See, as I told, cipher is combination of three things: mode, first algorithm, mode, and padding. If you go for documentation, like JC documentation, they have done some padding, supported padding, like PKCS7, PKCS8, PKCS12. These are the supported paddings. This Mulesoft guys are already implemented. But again, keep in mind, like uh, you use this JC padding, you pass it as a string, don't pass it as a fx function. So anything you pass it, here is a combination of algorithm, mode, and padding as a string format. These three things should be there, because this is a set. You cannot pass rsa and padding like this. This is a if you want pass only algorithm, just pass it algorithm, just disable this one, enable this. This is a mutually exclusive. Just encryption P base. Can we send credit card number as a number instead of string? Yeah, you can pass it anything. Data validations is not there here. You can encrypt any data. It's not only the string is confined. You can use XMLs. Anything you can do it. You can use text data also to encrypt. Okay, JC, can we send credit card number as number? Yeah, you can pass it. It's not like data type they are encrypting. I think. Sachin Narayana, I got question. Can you give examples of scenario where we should use JCPGP access? See, yeah, Daniel, I was already discussing. So JC again is it's a heavyweight, heavyweight as I told, and it's a different independent platforms. Symmetric and asymmetric is a different independent platforms. I think stop is a different independent platforms, and PGP it's a hybrid model. It's a combination of again it's a combination of data compression and all. XML, because XML is a legacy system, so nowadays XML is not used. Again, yeah, you can use XML in a scenarios where you have SOAP APIs, SOAP structures and all. They can use XML encryption. That's the scenarios we can use it. JC, you are working closely with some Java things and all those things, you can use JC. PGP, as I discussed, different flavors is available. PGP you can use in scenario where you use some data compression and all. I tried with JC and PGP. What I observed is like JC cannot handle big payloads. When you have requirement to have some big payloads to encrypt, JC giving cannot encrypting the data. In those scenarios, you go for PGP because it will handle big payloads, and the transmission rate is fast compared to JC. Got it? XML is again the soap service, and traditional XML, some traditional legacy systems. For any algorithm, be it PGP, JCX, can we encrypt specific field in the message? Let's say I have 10 fields in the message and I want to encrypt the field 2 and field A. Yeah, you can do it. As I told, XML have the XML have the XPath is available. So here I'm using C. So I'm not sending here total encryption. I'm using my message slash credit card. Only credit card is encrypted. Here in the encrypted data, only I'm only encrypting the data of credit card, not complete XML. So we can pass it. Even in JC also, we can implement the logic. So see, I implemented this logic, right? So using some lookup function, you can use some functions call this lookup. So only the particular fields I'm encrypting. So I'm not encrypting the total payload. I'm using only credit card. You can try to implement this type of logics. This can be possible.